All right, so welcome back to the next video. If you are already starting this video and you have not already looked at the video for 1 ABC or 2 ABC, that will be assumed that you understand those, and you should make sure that you understand those before you move on to this next video. So on this next one, I'm just going to quickly review D, E, F, and G on these aldehyde and ketone practice questions. So excuse the little timer in the back. We are making some lunch in the background, so don't even worry about any other sounds, as we are all, as my whole family here is trying to be as quiet as they can. So that being said, number 1D, still about heptane 3-one. Number 2, D is about heptanal. So number D is describing what observations would be expected from the Failings test, and same exact question for letter D on for heptanal. So first of all, I'm not going to give you the full answer, but I will describe it to you here as a reminder that this is a ketone. So that you please see the reading about the properties of aldehydes and ketones, which is also linked on the website at this point. The main thing that you would need to be able to describe that you would expect from a Failings test is that it would not form a dark red precipitate. So quick reminder, and similar to 2D, the question is the same. This is an aldehyde. See the reading about aldehydes. So again, the main thing is that it will form a dark red and brownish precipitate. So those are the main things that you would need to know for the Failings test for the ketone and the aldehyde. And so then coming back to then letter E is going to be draw how a nucleophile, like this in this case, this is copper 1 oxide, would interact with a molecule. Same idea here. So I am doing a very simplistic, I'm checking these off already, very simplistic question, way to describe this. I'm not expecting there to be a huge detailed you showing what this nucleophile copper 1 oxide looks like. It is a lot more, a Failings test is a lot more molecules, a lot more atoms, and the molecules are significantly more complex. But the main thing about a nucleophile is remembering that a nucleophile is a negatively charged ion or a negatively charged molecule that goes in and to attack a nucleus, is attracted to a nucleus. So remembering that that's what a nucleophile is. So if I was to draw that on this heptane 3-one, so this is what it would look like for a heptane 3-one. So here's that drawing of that heptane 3-one. You have that slightly positive part of this carbon. I've shown this with the slightly, the symbol for slightly negative, slightly positive. This nucleophile, this copper 1 oxide is attracted to there, but it's not a strong enough nucleophile. So there would be no reaction, there'd be no oxidation. The copper 1 oxide is not a strong enough nucleophile, as you saw that I wrote. On the other hand, if I was to then have a nucleophile of copper 1 oxide on this heptanal, this heptanal, kind of coming over here, you would have this copper, this negatively charged nucleophile being attracted to this carbon here. Remembering that this carbon bond is fairly strong, but this carbon hydrogen bond is not as strong of, it's going to essentially, you can think of this bond right here being kind of a weakling. It's not going to be able to be oxidized as easily. So when this nucleophile comes in and essentially attacks the nucleus of this slightly positive carbon on the carbonyl group of the aldehyde, it will be oxidized. So it would look like this. There are other products in this reaction. Please notice that we still have copper that would be accounted for, but the main thing that I want you to be able to identify is that we had this oxidation here. We now have, and this oxygen has been added to this molecule. This aldehyde is now no longer the aldehyde. It is now going to lead us to what letter F and G are going to kind of get us to. So with that being said, so we have now completed number 1E, I've already checked it out. We have completed 2E for both of those on there. So F and G, I'm gonna just do together really fast. F is asking, can this molecule be oxidized with a valence test? G, true or false, under acidic conditions. Please notice under acidic conditions. Under basic conditions, it would be different. It would be, it would not be different for number 1, but it would be different for the answer in number 2. So under acidic conditions, the product formed from the valence test with this molecule can be used for esterification. In this case, because it is a ketone, we are going to circle false. And letter G on number 2 would be considered to be true. So know that that letter G, I'm going to need to answer the name of this product. So that being said, I'm gonna go through F and G on both of these. So F on here, F for that heptane 3-one cannot be oxidized. Heptanal for can be oxidized. So G in this case, it would be false. We don't need to write anything else. But for G, what we would then need to write is we'd write true. But because we do have a name, if it is true, what would be the name of the product? This is the product that we then formed. So right here, the name of this product that we formed would be heptanoic acid. So know that heptanoic acid, as a reminder, esters are made from a carboxylic acid. This is a carboxylic acid, remembering that this is your functional group for the carboxylic acid, and an alcohol. So, and an alcohol, as I saw that was off the screen a little bit. So that is number 1 and 2 complete. So we are done with number 1 and 2. I will go a little bit faster with 3 and 4, but you can see those on the next video.